Microsoft Azure AI Fundamentals will give you foundational knowledge on machine learning, artificial intelligence concepts, and other Microsoft Azure core services. This AI-900 certification will give you perfect opportunity to demonstrate your knowledge on ML and AL related workloads in Microsoft Azure. Just like the other courses, I will make sure to put the timestamps on all of the topic I discuss in this course right below the like button, so it is easier for you to navigate between these topics. You can use the skills what you are acquiring in this course as a stepping stone for Azure Data Engineer certification or Azure AI Engineer Associate certifications. I hope the information provided in this course is super helpful, and I wish you all the very best for your examination and continued career success. Let's have a look at the skills what you are going to be measured on this particular exam. This course is designed for anyone who want to learn about artificial intelligence and services in Microsoft Azure. So we have 5 modules and different weightages. The higher the weightage, the more questions you can expect out of these modules. I have prepared this certification course and divided into 5 different modules. The first module, we start with Introduction to AI. In this module, you will learn about the common uses of artificial intelligence and different types of workload associated with AI. In the second module, you will learn about some fundamental machine learning concepts and how to use machine learning service to create and publish machine learning models. And in the third module, it's all about computer vision. Computer vision is the area of AI that deals with understanding the world visually through images, video files, and cameras. And in that module, I will take you through multiple computer vision techniques and services. And the fourth module is all about natural language processing. And you will learn about Azure services that can be used to build solutions that analyze text and recognize and synthesize speech and translate between languages and interpret commands. And the last module is all about conversational AI. Conversational AI enable users to engage in a dialogue with an AI agent or bot through communication channels such as email, web chat interfaces, social media, and others. And in the last module, I will give you some basic principles on working with bots. If this is the first Microsoft examination you are going to sit, please expect between 40 to 60 questions, and these questions worth more than 1 point. So if you don't happen to know any particular answers, please don't worry about it. There is no negative mark in Microsoft certification. So try to answer all the questions. On total, you would have 180 minutes, but plan for 150 minutes for answering the question and rest of the time for commenting, reporting, and other instruction. And if you're wondering what type of questions you get, there is more than just multiple choice questions. Sometimes you get a built list, hot area, active screen, or drag and drop. And there are not going to be any case studies on AI-900, but on all advanced Microsoft certification, please expect to have a lab or case studies. All right, so without wasting any more time, let's go and start our first module, which is all about Introduction to AI. So what is artificial intelligence? Simply put, artificial intelligence is the creation of software that imitates human behaviors and capabilities. Some of the key elements include making decisions based on data and past experience, detecting anomalies, interpreting visual input, understanding written and spoken language, and engaging in dialogues and conversations. Some of the most common artificial intelligence workloads are machine learning, anomaly detection, computer vision, natural language processing, and conversational AI. So let's look into those in detail. So what you see on this slide is some of the common workloads or areas of AI. Let's start with machine learning. Machine learning is often the foundation of an AI system and is the way we teach a computer model to make prediction and draw conclusion from data. What about anomaly detection? Anomaly detection is the capability to automatically detect errors or unusual activity in a system. Computer vision is the capability of software to interpret the world, usually through cameras, videos, and images. Natural language processing, or NLP, is the capability for a computer to interpret written or spoken language and respond in kind. And the last one is conversational AI. Conversational AI is the capability of a software agent, usually referred to as a bot, to participate in a conversation. We will explore each of these workloads in detail in the coming slides and coming videos. So please keep that in mind. When you design an AI solution, many of these workloads may overlap. So let's have a look at what are the solutions available within Microsoft Azure which can help you create artificial intelligence solutions. Microsoft Azure provides a scalable, reliable cloud platform for AI, which include the solution for your data storage, your compute resources, and plenty other services which you can integrate with your solution. So let's have a look at some of the key AI related services in Azure. Again, we will go in detail about these topics in the coming videos. So let me introduce you to these solutions. The first one is Azure Machine Learning. This is a platform for training, deploying, and managing machine learning models. The second one is Cognitive Services. Cognitive services include a suite of services developers can use to build AI solutions. And the last, not the least, is Azure Bot Service. This is a cloud-based platform for developing and managing bots. So now I have introduced you to what is artificial intelligence and what are the solutions available within Azure. In the next video, we're going to talk about what is responsible AI. Let us understand the challenges and risk associated with artificial intelligence. Artificial intelligence is a powerful tool that can be used to greatly benefit the world. However, like any tool, it must be used responsibly. So let me show you some of the potential challenges or risk faced by an AI developer. The first one is bias can affect results. Let's look at the first example on this. An example could be a loan approval model discriminates by gender due to bias in the data with which it was trained. Another challenge or risk is errors may cause harm. An example of this is an autonomous vehicle experiences a system failure and causes a collision. And the third challenge or risk could be data could be exposed. An example of this risk is a medical diagnostic bot is trained using sensitive patient data which is stored insecurely. Let's look at the next challenge. Solutions may not work for everyone. An example of this risk is a home automation assistant provides no audio output for visually impaired users. Another risk is user must trust a complex system. An example of this risk is an AI-based financial tool makes investment recommendation. And what are they based on? Let's look at one more challenge. Who is liable for AI-driven decisions? An example of this challenge would be an innocent person is convinced of a crime based on evidence from facial recognition. So who is responsible for that? So these are some of the things we need to keep in mind, certain challenges and the risk which is faced with AI. At Microsoft, AI software development is guided by a set of 6 principles designed to ensure that AI applications provide amazing solutions to difficult problems without any unintended negative consequences. So these 6 principles are fairness, reliability and safety, privacy and security, inclusiveness, transparency, and accountability. You can know more about it by going into this website which I mentioned over here.
Let me take you through each one by one. So, what is fairness? AI systems should treat all people fairly. For example, suppose you create a machine learning model to support a loan approval application for a bank. The model should make predictions of whether or not the loan should be approved without incorporating any bias based on gender, ethnicity, or other factors that might result in an unfair advantage or disadvantage to specific group of applicants. Azure machine learning includes the capability to interpret models and quantify the extent to which each feature of the data influenced the model prediction. This capability helps data scientists and developers identify and mitigate bias in the model. Let's understand reliability and safety. AI systems should perform reliably and safely. For example, consider an AI based software system for an autonomous vehicle or on a machine learning model that diagnoses patient symptoms and recommends prescriptions. Unreliability in these kind of system can result in substantial risk to human life. AI-based software application development must be subjected to rigorous testing and deployment management process to ensure that they work as expected before release. Let's understand privacy and security. AI systems should be secure and respect privacy. The machine learning models on which AI systems are based rely on large volumes of data, which may contain personal details that must be kept private. Even after the models are trained and the system is in production, it uses new data to make predictions or take action that may be subject to privacy or security concerns. Let's understand about inclusiveness. AI systems should empower everyone and engage people. AI should bring benefits to all part of the society, regardless of physical ability, gender, sexual orientation, ethnicity, or other factors. And what about transparency? Artificial intelligence system should be understandable. Users should be made fully aware of the purpose of the system, how it works, and what limitations may be expected. And let's understand about accountability. People should be accountable for artificial intelligence systems. Designers and developers of AI based solutions should work within a framework of governance and organizational principles that ensure the solution meets ethical and legal standards that are clearly defined. So let me take you to Microsoft Responsible AI site. This is a one-stop place where you can understand the responsible AI features. This is where you can understand what are the responsible AI practices Microsoft is following. You can go under each topic and play this video to understand more. And listen to these experts what they talk about these responsible AI topics. Next, I want to take you through the guidelines for human AI interaction demo. For that, go to aka.ms/hci-demo. This is where you would be able to learn more about the guidelines of human AI interaction. There are different cards on each deck, and you can click on each to review the example scenarios. There are 4 decks available. So first one is initially when you make an intent. The second one is during an interaction. And the third deck is all about when an AI system is wrong. And the final one is over time, how would you notify or give you information about these scenarios? So let's pick the first example. This is an example of Microsoft letting everyone know about their Office new companion experiences. And by upfront, Microsoft tells what it can do and how it can do it. So it is very transparent from the very beginning. Another example where Apple Music is letting user know that we think you will like. It's not that they are pushing this idea into your mind. It's a recommendation based on what the system thinks. And last example is all about the Outlook web email, explain what are the filtering they do based on the focused email mailbox, etc. So it is letting you the intent at the very beginning. Let's pick another card from the next deck, which is during interaction. My analytics let you know that how it is using your data to help you work smarter. So during the interaction itself, it is giving you more insight into how this can help you change your life in terms of your work-life balance, etc. And within Bing, when you search about a doctor, it brings you details like it brings you CEOs or doctors, which shows images of diverse people, not just not just focusing on a particular gender or ethnicity. Let's pick another card from the third deck, which is when wrong. This is where the system make clear why the system did what it did. So the first example shows Microsoft Online recommending the documents based on your history and activity. So it is showing that you are seeing this recommendation based on what you have done in the past. Let's look at the next example. This is where Amazon recommend you a different product. And when you want to know why Amazon recommended this product, you can click on why recommended to understand what are the patterns it used to came up with this conclusion. And let's look at the third example. And in Facebook, you might see some ads, and Facebook enable you to access these explanation about why you are seeing each ad in the newsfeed by clicking on the information. And the last one is over time, what are the information it learning? The first example show you how the system is notifying users about the change. In this example, the system clearly show that what's new is going to show you all the latest features and update which included in the AI features. So this is the place all of you can come and have a look at all these cards and look at the different examples to show you different guidelines for human AI interactions. So I hope the information provided was useful. In the next video, we are entering a brand new module. The module 2 is all about machine learning. And the first lesson we are going to learn on module 2 is about introduction to machine learning. So what is machine learning? Machine learning is the foundation for most AI solutions and enables the creation of models that predict unknown values and infer insights from observed data. So how do machines learn? So the answer is from data. In today's world, we create huge volumes of data as we go about our everyday lives. From the text messages, emails, social media posts, the photos, what we take on our phones, we generate massive amounts of information. More data still is created by millions of sensors in our home, cars, cities, and public transport infrastructure and factories. So data scientists can use all of that data to train machine learning models that can make predictions and inferences based on the relationship they find in the data. For example, suppose an environmental conservation organization wants volunteers to identify and catalog different species of wildflower using a phone app. So I'm going to show you an animation which shows how machine learning can be used to enable for this particular scenario. The first task is for a team of botanists and data scientists to collect samples of these wildflowers. If you notice, each sample has some features such as measurement of the pellets, stem, and other details. And the botanist can provide a label for the flower using its species name. So what you see over here is the Latin name of these flower species. The next step is, and the sample data is then processed using the algorithm that tries to find a relationship between the features and the label. So now the label data is processed using an algorithm that finds relationship between the features of the samples and the label features. The next step is the result of the algorithm are encapsulated in a model. And since the model has learned the relationship between the features and the label, you can use it to predict the species of a flower based on its features. And when a new samples are found by the volunteers, the model can identify the correct species label. So that was a quick example about machine learning model. So let's understand what is regression. Regression is a form of machine learning that is used to predict a numeric label based on an item's features. For example, suppose Adventure Work Cycle is a business that rents cycle in a city. The business could use historic data to train a model that predicts daily rental demand in order to make sure that sufficient staffs and cycles are available. To do this, Adventure Work could create a machine learning model that takes information about specific day, example, the day of the week, the expected weather conditions, and so on, as an input, and produces the permitted number of rentals as an output. So let's look at an example and get an idea of how it works. There is a little mathematics involved, but don't worry, the basic idea is fairly straightforward. For this example, we will restrict this to just the temperature and the number of rentals per day. In reality, there would be more factors to consider. The number of rentals is the label we are going to predict, and we are going to use the daily temperature as the feature on which the base the prediction. Generally, we refer to this feature as X and the label as Y. We are going to do this to try to figure out a function that we can apply to X to get to the value of Y. So as you notice, X appears above as the temperature column and Y appears above as the rentals column. And when we find a function, we will need to validate it with some data for days where we already know the number of rentals, so we can see how well it predicts. As you notice, I split this table into training subset and validation subset. So looking at the plot, you can see a trend in which higher temperature tend to correlate with more rentals. In fact, we can fit a line between these plotted points that more or less describes this correlation. And we can use this line to work out a calculation that produces Y from X. The point where the line interprets with the Y-axis is around 35. So the function that operates on X to find Y is 35 plus 1.5 times of X. Now we can test this function with the validation data that we held back. So here are the values we get from the function for the temperature on these days. So let's plot the actual values from the validation data along with the line from which the predicted values were calculated. Now we can see how well the model predicts by measuring the difference between the predicted values and the actual values that we know to be true. Let's understand what is classification. Classification is a form of machine learning that is used to predict which category or class an item belongs to. For example, a health clinic might use the characteristics of a patient, such as age, weight, blood pressure, and so on, to predict whether the patient is at risk of diabetes. And the label is a classification of either 0 or 1, representing non-diabetic or diabetic. Like regression, classification is an example of a supervised machine learning technique in which you train a model using data that includes both the features and non-values for the label, so that the model learns to fit the features combined to the label. Then after the training has been completed, you can use the trained model to predict labels for new items for which the labels is unknown. Let's understand clustering. Clustering is a form of machine learning that is used to group similar items into clusters based on their features. For example, a botanist might take measurements of plants and group them based on similarities in their proportions. And clustering is an example of an unsupervised machine learning in which you train a model to separate items into clusters based purely on their circumstances or features. There is no previously known cluster value or label from which to train the model. So that concludes the first lesson of machine learning. In the next lesson, we're going to talk about Azure machine learning. So what is Azure machine learning? Microsoft Azure provides the Azure Machine Learning Service, a cloud based platform for creating, managing, and publishing machine learning models. Azure Machine Learning provides the features like automated machine learning, data and compute management, pipelines, Azure Machine Learning Designer, etc. So let's have a look at what is automated machine learning. Automated machine learning in Azure Machine Learning provides the easiest way to train a machine learning model for regression or classification. There is a visual interface for automated machine learning in the Azure Machine Learning Studio web portal. You just need to supply the training data and select the required model type, and Azure ML does the rest. Automated machine learning helps data scientists to increase their efficiency by automating many of their time consuming. Automated machine learning helps data scientists increase their efficiency by automating many of the time consuming tasks associated with training models. And it enables them to use cloud based compute resources that scales effectively to run multiple training equipments in parallel while incurring cost only when they actually being used. So let me quickly show you the Azure Machine Learning Studio instance. I'm going to select the directory and the subscription it belongs to. Since I don't have any existing workspace, I'm going to create a new workspace. First step is I'm going to create a new resource group and create a workspace name and click on Review Create. So while this is creating, let us go and learn what is Azure Machine Learning Designer. In Azure Machine Learning, multi-step workflows to prepare data, train models, and perform model management tasks are called pipelines. The Designer tool in the Azure Machine Learning Studio enables you to create and run pipelines by using a drag and drop visual interface to connect modules that define the steps and data flow for the pipeline. So let me show you what is Azure Machine Learning Studio and Azure Machine Learning Designer. So Azure Machine Learning Service has been created. I'm going to click on Go to Resource. So now we have our studio created. I can click on Launch Now to launch the Azure Machine Learning Studio. Because this is a brand new studio we created, let's take a tour. When it comes to authoring, this is where you can use notebooks, automated ML, and Designer to build, train, and evaluate and deploy machine learning models using this authoring tool. The next set of assets like data sets, experiments, pipelines, models, and endpoints will help you prepare your data and run and monitor your jobs, view and deploy models, and manage real-time pipeline endpoints. And the last set of management tool includes compute, data stores, and data labeling. This is where you can come and view and manage resources for your workspace. If you have multiple workspace, this is where you can switch between this workspace in your subscription. If you're doing it for the first time and you want some sort of a help and tutorials and documentation, you can find it over here. And you can always provide feedback to Microsoft by clicking on the smiley icon. And let me show you how you can access the Azure Machine Learning Studio Designer. So you can click on this Designer. You can either create a easy to use pre-built module, or you can create a standard template available based on image classification, binary classification, and other examples. So I'm going to select one. And this is the designer I was talking about before. So you can use the predefined designer available, and then you can use this model and customize for your requirement as well. So since this is AI-900, which is fundamentals of artificial intelligence, theoretical knowledge around what this is and what are the use case scenarios is all you need for this examination. So that concludes module 2, which was all about machine learning. In the next video, we're going to start a brand new module, which is all about computer vision. The first lesson we're going to learn is computer vision concepts. So what is computer vision? Computer vision is one of the core areas of artificial intelligence and focuses on creating solutions that enable AI-enabled applications to see the world and make sense of it. Of course, computers don't have biological eyes that work the way ours do, but they are capable of processing images either from a live camera feed or from digital photographs or videos. This ability to process images is the key to creating software that can emulate human vision perception. To an AI application, an image is just an array of pixel values. These numeric values can be used as features to train machine learning models that can make predictions about the image and its contents. Most computer vision solutions are based on machine learning models that can be applied to visual input from cameras, videos, and images. So, what I have listed over here are some of the common applications of computer vision. Those are image classification, object detection, semantic segmentation, image analysis, face detection and recognition, optical character recognition, etc. So, I'm going to take you through one by one. Image classification involves training a machine learning model to classify images based on their contents. For example, in a traffic monitoring solution, you might use an image classification model to classify images based on the type of vehicle they contain, such as taxis, buses, cyclists, and so on. Object detection machine learning models are trained to classify individual objects within an image and identify their location with a bounding box. For example, a traffic monitoring solution might use object detection to identify the location of different classes of vehicle. Semantic segmentation is an advanced machine learning technique in which individual pixels in the image are classified according to the object to which they belong. For example, a traffic monitoring solution might overlay traffic images with mask layers to highlight different vehicles using specific colors. So, what is image analysis? You can create solutions that combine machine learning models with advanced image analysis techniques to extract information from images, including tags that could help catalog the image or even descriptive captions that summarizes the image shown in the image, like a person with a dog is on a street. The next one is face detection, analysis, and recognition. The face detection is a specialized form of object detection that locates human faces in an image. This can be combined with classification and facial geometry analysis techniques to infer details such as age and emotional state, and even recognize individuals based on their facial features. The last one is optical character recognition, or OCR. The optical character recognition is a technique used to detect and read text in images. You can use OCR to read text in photographs, for example, road signs or storefronts, or to extract information from scanned documents such as letters, invoices, or forms. Now let's see the computer vision in action. So I'm going to demonstrate a couple of examples on how this whole computer vision concept work. I'm going to go back to my browser, go to aidemos.microsoft.com and select computer vision. The first one is analyze and describe images. I'm going to select an image to see what it is going to describe. As you can see that when I selected this image, it identified buildings with 100% confidence. There are buildings. There is car, road, outdoor, sidewalk. It is not that sure, but still we can see there is a sidewalk. Then it identified the color yellow from the taxi, and it clearly identified that this is outdoor. That is one example. Let me go back and pick another image. All right, let's look at the tags. So this time, the computer vision identified there is water, skyscrapers, reflection, there is a lake, sky, and it thinks it's a day. Actually, it is a day. And you can find out the description as well. Let's go to the next step. The next one is read a text in the imagery. So this is what we learned about OCR. So I'm going to click on an image, and there is some text on that image. So it identifies that there is text, which is transcribed as 42 Street 42. Let's try another image, for example. I'm going to pick this one. So there is some text on this picture as well. But this OCR rightly recognized these texts from this image. Let's check the next one, which is read handwriting in an imagery. I'm going to pick an image, and based on that image, it says that steel cut oats, apricots. So pretty much everything from that image is being automatically transcribed from that model. You pretty much get the idea, right? Let's look at one more example. This time we're going to recognize celebrities and landmarks. So I'm going to pick Satya. With 100% confidence, the system says that it's Satya Nadella. I'm going to pick one more image to see if it identifies that landmark. Yep. With 99% confidence, the computer vision says that it's White House. So that was a quick example on the demonstration on computer vision. In the next video, we're going to go through computer vision in Azure. Azure provides a set of cognitive services that encapsulate common AI workloads, including computer vision tasks. To use cognitive services, you must provision a resource in an Azure subscription. This can be a standalone or service-specific request, for example, a computer vision resource or general cognitive services resource. Using a standalone service-specific resource enable you to manage cost and access to that service independently of other services you may be using. While a general cognitive services resource enable you to combine all of your AI service in a single Azure resource for centralized management. Regardless of your type of resource you use, client application will consume the service it provides by connecting to REST endpoints using resource-specific key for authentication. The computer vision cognitive service provide a pre-trained computer vision model that can be used to analyze images. The first step towards using the computer vision service is to create a resource for it in your Azure subscription. You can either use a computer vision or cognitive services. So let me show you how to do that first. So I'm on my Azure portal right now. I'm going to go to all services, and this time I'm going to search for cognitive services. So I don't have any cognitive services. I'm going to click on create a cognitive services. This takes me to the cognitive services. So now I have an ability to create either a computer vision. So here I can search for computer vision or cognitive services. So this computer vision is a specific resource for computer vision service. We can use this resource type if you don't intend to use any other cognitive services, or if you just want to track utilization and cost of your computer vision resources separately. Another one is cognitive services. I'm going to go back. So this time I've searched for cognitive services. A general cognitive service resource that include computer vision along with many other cognitive services such as text analysis, translator test, and others. You can use this resource type if you plan to use multiple cognitive services and want to simplify administration and development. Whichever type of resource you choose to create, it will provide two pieces of information that you will need to use it. Basically, it asks you for a key and the endpoint. A key is used to authenticate client application, and an endpoint that provides the HTTP address at which your resources can be accessed. Let's understand the training models with the custom vision service. The custom vision cognitive service enable you to train a custom model for either image classification or object detection. Image classification is a machine learning technique in which the object being classified is an image, such as a photograph. As with any form of classification, creating an image classification solution involves training a model using a set of existing data for which the class is already known. In this case, the existing data consists of a set of categorized images, which you must upload to the custom vision service and tag with appropriate class labels. After training the model, you can publish it as a service for application to use. The next one is object detection. Object detection is a form of machine learning based computer vision in which a model is trained to recognize individual type of object in an image and to identify their location in the image. Creating an object detection solution with custom vision consists of three main tasks. First, you must use upload and tag images. Then you can train the model. And finally, you must publish the model so that client application can use it to locate object in images. Creating an image classification or object detection solution with custom vision requires a resource in your Azure subscription. You need two types of resources: a custom vision and a cognitive services. A custom vision is a dedicated resource for custom vision service, which can be either training or a prediction resource. And the previous example, the cognitive service is a general cognitive service resource that include custom vision along with many other cognitive services. You can use this type of resource for training, prediction, or both. So, what is model training? To train a custom vision model, you must upload images to your training resource and label them with the appropriate class labels or object boundary boxes. Then you must train the model and evaluate the training results. You can perform this task in the custom vision portal, or if you have the necessary coding experience, you can use one of the custom vision service programming language SDKs. Let's understand how you can analyze faces with the face service. Face detection and analysis is an area of artificial intelligence in which we use algorithms to locate and analyze human faces in images or video content. The first one is face detection. The face detection involves identifying regions of an image that contain human face, typically by returning bounding box coordinate that from a rectangle around the face, like what I have shown in this image. The next one is facial analysis. Moving beyond simple face detection, some algorithms can also return other information such as facial landmark, nose, eyes, eyebrows, lips, and others. These facial landmarks can be used as feature with which to train a machine learning model from which you can infer information about a person, such as their age or perceived emotional state. Like what I have mentioned in this image, the age is 25, anger 0, that means that maybe she's not angry, and happiness, there is a value of 1.0, that means she's maybe happy. The next one is facial recognition. A further application of facial analysis is to train a machine learning model to identify known individuals from their facial features. This usage is more generally known as facial recognition and involves using multiple images of each person you want to recognize to train a model so that it can detect those individuals in new images on which it wasn't trained. The next capability is reading text with computer vision service. The ability for computer systems to process written or printed text is an area of artificial intelligence. You need computer vision capabilities to read the text and then need natural language processing capabilities to make sense of it. The basic foundation of processing printed text is optical character recognition or OCR, in which a model can be trained to recognize individual shapes as letters, numerals, punctuations, or other elements of text. Much of the early work on implementing this kind of capability was performed by postal services to support automatic sorting of mail based on postal codes. Since then, the state of the art of reading text has moved on, and it is now possible to build models that can detect printed or handwritten text in an image and read it line by line or even word by word. So, what are the use cases of OCR? You can use OCR for note taking, digitizing forms such as medical records or historical documents, scanning printed or handwritten checks for bank deposit, etc. The next one is analyzing forms with form recognizer service. A common problem in many organizations is the need to process receipt or invoice data. For example, a company might require expense claims to be submitted electronically with scanned receipts. It's relatively easy to scan receipts to create digital images or PDF documents, And it's possible to use optical character recognition or OCR technologies to extract the text contents from the digitized documents. However, typically, someone still need to review the extracted text to make sense of the information it contains. Increasingly, organizations with large volume of receipts and invoices to process are looking for artificial intelligence solution that can not only extract the text data from the receipts but also intelligently interpret the information they contain. So that concludes module 3. In the next video, we're going to start a brand new module called Natural Language Processing or NLP. And the first lesson is Introduction to NLP. So, what is natural language processing? NLP or natural language processing is the area of AI that deals with creating software that understands written and spoken language. NLP enables you to create software that can analyze text document to extract key phrases and recognize entities such as places, dates, and people. NLP can enable you to perform sentimental analysis to determine how positive or negative the language used in a document is. And NLP can help you interpret spoken language and synthesize speech responses. And NLP can automatically translate spoken or written phrases between languages as well. And finally, you can use NLP to interpret commands and determine appropriate actions. In Microsoft Azure, you can use text analysis, translated text, speech, and language understanding. For example, you can use text analysis to analyze text documents and extract key phrases. And you can detect entities and evaluate sentiment positive or negative in the document as well. Another service is translated text. You can use this service to translate between more than 60 languages. The next one is speech. You can use the speech service to recognize and synthesize speech and to translate spoken languages. And the last one is language understanding. You can use this language understanding service to train a language model that can understand spoken or text based commands. The natural language processing includes several services. So let me take you through these services one by one. Let's start with text analysis. The text analysis service is part of the Azure Cognitive Service offering that can perform advanced natural language processing over raw text. To use the text analytics service in an application, you must provision an appropriate resource in your Azure subscription. Then you can either choose a text analysis or a cognitive services. The next one is language detection. You can use the language detection capability of the text analysis service to identify the language in which the text is written. You can submit multiple documents at a time for analysis. For each document to be submitted to it, the service will detect the language name. For example, is it English? The ISO 6391 language code, for example, EN for English, ES for Spanish, and a score indicating a level of confidence in the language detection. For example, consider a scenario where you own and operate a restaurant where customers can complete surveys and provide feedback on the food, the service, staff, and so on. Suppose you have received the following reviews from the customer. Based on the first reviewer says that it's a fantastic place for lunch and the soup was delicious. The second statement is, I can't even read it because I don't understand Spanish. But you get the point, right? The language detection service detect all three and predicted the language, the code, and the score. As you can see that on the third one, it's a combination of, I think, French or Spanish and English. So the confidence level is not high. The next one we need to understand is sentiment analysis. The text analysis service can evaluate text and return sentiment score and labels for each sentence. This capability is useful for detecting positive and negative sentiment in social media, customer reviews, discussion forums, and more. Using the pre built machine learning classification model, the service evaluates the text and returns a sentiment score in the range of 0 to 1, with values closer to 1 being a positive sentiment, and scores that are close in the middle range are considered neutral and intermediate. These are the two examples based on the review from a restaurant. So you can read out and figure out like why this one is rated high and the second review is later rated low. Because in the second review, you can see that the food was awful, and based on this word, the sentiment analysis predict that this customer review is poor. So, what is key phrase extraction? Key phrase extraction is the concept of evaluating the text of a document or documents and then identifying the main points around the context or context of the documents. Consider the restaurant scenario discussed previously. Depending on the volume of surveys you have collected, it can take a long time to read through the reviews. Instead, you can use a key phrase extraction capability for the text analysis service and let the AI algorithm do the work for you. The next one is speech recognition and synthesis. Increasingly, we expect artificial intelligence solution to accept vocal commands and provide spoken responses. Consider the growing number of home and auto systems that you can control by speaking to them, issuing commands such as turn off the lights, and soliciting verbal answers to questions such as what's the weather today like or will it rain today. To enable this kind of interaction, the AI system must support two capabilities. The first one is speech recognition, and the second one is speech synthesis. In the speech recognition, gives you the ability to detect and interpret spoken input, and the speech synthesizes gives the ability to generate spoken output. And Microsoft Azure offers both speech recognition and speech synthesis capabilities through the speech cognitive service. To use the speech service in an application, you must provision an appropriate resource in your Azure subscription. You can either use speech resource or a cognitive service. Let's understand the speech to text API. You can use the speech to text API to perform real time or batch transcription of audio into a text format. The audio score for transmission can be real time audio stream for a microphone or an audio file. The next one is real time transcription. The real time speech to text allows you to transcribe text in audio streams. You can use real time transcription for presentations, demo, or any other scenario where a person is speaking. And the third one is batch transcription. Not all speech to text scenarios are real time. You may have audio recordings stored on a file share, a remote server, or even on Azure storage. You can point to audio files with a shared access signature and asynchronously receive transcription results. And under the text to speech API, enables you to convert text input to audible speech, which can either be played directly through a computer speaker or written to an audio file. So let's understand machine translation. As organizations and individuals increasingly need to collaborate with people in other cultures and geographic locations, the removal of language barriers have become a significant problem. One solution is to find bilingual or even multilingual people to translate between languages. However, the scarcity of such skills and the number of possible language combination can make this approach difficult to scale. Increasingly, automated translation, sometimes known as machine translation, is being employed to solve this problem. A literal translation is where each word is translated to the corresponding word in the target language. This approach presents some issues. For one case, there may not be an equivalent word in the target language. Another case is where literal translation can change the meaning of the phrase or not get the context correct. And the second one is text and speech translation. The text translation can be used to translate documents from one language to another, translate email communication that come from foreign governments, and even provide the ability to translate web pages on the internet. Many times, you will see a translate option for posts on social media sites, or the Bing search engine can offer to translate entire web pages that are turned in search result. Speech translation is used to translate between spoken languages and sometimes directly, which is speech to speech translation, and sometimes by translating to an intermittently text format, which is speech to text translation. Microsoft Azure provides cognitive services that support translation. Couple of services are translator search and speech. So let me show you where to find that. I'm on my Azure portal. So under AI and machine learning, I'm going to search for translator text. This is a service which supports text to text translation. This translator text service is easy to integrate in your applications, websites, and tools and solutions. This service uses a natural machine translation or NMT model for translation, which analyzes the semantic context of the text and renders a more accurate and complete translation as a result. Another service is speech, and the speech translation service includes speech to text, text to speech, and speech translation as well. And you can use the speech translation API to translate spoken audio from a streaming source, such as a microphone or audio file, and return the translation as text or an audio stream. This enables scenarios such as real time closed captioning for speech or simultaneous two-way translation for a spoken conversation. Let's learn about the language understanding capability of artificial intelligence. As AI grows ever more sophisticated, conversational interactions with applications and digital assistants is becoming more and more common, and in specific scenarios can result in human-like interactions with AI agent. Common scenarios for this kind of solution include customer support applications, reservation system, and home automation, among others. To enable these kind of conversational solutions, computers need not only be able to accept language as an input, but also to be able to interpret the semantic meaning of the input. In other words, understanding what is being said. On Microsoft Azure, language understanding is supported through Language Understanding Service. To work with the Language Understanding Service, you need to take into account these three concepts: utterance, entities, and intents. An utterance is an example of something user might say and which your application must interpret. For example, when using a home automation system, a user might be using following utterances: switch the fan on or turn on the light, etc. An entity is an item to which an utterance refers. For example, a fan and a light in the following utterances. An intent represents the purpose or goal expressed in user's utterance. For example, for both the previously considered utterance, the intent is to turn a device on. So in your language understanding application, you might define a turn on intent that is related to these utterances. Creating a language understanding application consists of two main tasks. First, you must define entities, intents, and utterances with which to train the language model, referred to as authoring the model. Then you must publish the model so that client application can use it for intent and entity prediction based on user input. For each of the authoring and prediction tasks, you need a resource in your Azure subscription. The two services you need in Azure are language understanding and cognitive services. So let me show you where you can find language understanding. So I'm on my Azure portal. Go to create a new cognitive service, and under the catalog, search for language understanding. So this is a dedicated resource for language understanding, which can be either an authoring or a prediction resource. So that concludes the first lesson in natural language processing. In the next video, we're going to learn about using NLP services. The text analysis service, as its name suggests, is used to analyze text document. For example, suppose you use the text analysis service to analyze the text, I had a wonderful vacation in France. The text is, I had a wonderful vacation in France. The next one is the service can determine the language the text is written in. So this time it identified the text is written in language which is English. And the next step is it can evaluate the sentiment of the text. As you notice, the sentiment is 88%, which is positive. And the next step is it can detect key phrases used in the text. The key phrases such as wonderful vacation. And the last one is it can identify known entities that are mentioned, which is France. So let's look at the next example. In this example, we are going to look at an example on speech recognition and synthesis. The speech service provides a speech to text API that you can use to implement text recognition functionality. The service supports text transcription in more than 60 languages. Conversely, the text to speech API can synthesize audio speech from text with the option to specify regionally appropriate voices like human like pronunciations. Let's look at the next example. In this example, we are going to look at translation. The translation text service enables you to translate text between more than 60 languages. As you notice, the text called bonjour is translated to hello. And you can also translate audible speech by using speech service, which has the ability to produce translated output in text or audio format. And when the hello bubble is submitted to the speech service, it returns the value as hola and something in Chinese. I'm sure it is hello in Chinese. Let's look at the next example, which is language understanding. The language understanding service enables you to train a language model that can interpret natural language commands. The first one is utterances. Utterances are phrases that a user might say or type. For example, switch the light on. The next one is entities. Entities are specific items that can be referenced in the utterance. For example, a language model for a home automation appliance might recognize household devices such as light or a fan. And the third one is intent. An intent identifies the desired action for the utterance. For example, to switch something on. So we just completed module 4, which is all about NLP. In the next video, we're going to start a brand new module, which is called Conversational AI. And the first lesson is Conversational AI Concepts. In today's connected world, people use a variety of technologies to communicate. We use voice calls, messaging services, online chat applications, social media platforms, email, and collaborative workplace tools. We have become so used to this ubiquitous connectivity and that we expect the organization we deal with to be easily contactable and immediately responsive through the channel we already use. Additionally, we expect these organizations to engage with us individually and to be able to answer complex questions at a personal level. So, what is conversational AI? While many organizations publish support information and answers to frequently answered questions or FAQs that we can access through a web browser or dedicated app, the complexity of the system and services they offer means that answers to specific questions are hard to find. Often, these organizations find their support personnel being overloaded with requests for help through phone calls, email, text messages, social media, and other channels. Increasingly, organizations are turning to artificial intelligence solutions that make use of AI agents, commonly known as bots, to provide a first line of automated support through the full range of channels that we use to communicate. Bots are designed to interact with users in a conversational manner, as shown in the example in the chat interface. So I have shown an example here of a chat interface. You might have seen something similar on a website, but bots can be designed to work across multiple channels, including email, social media platforms, and even voice calls. Regardless of the channel used, bots typically manage conversational flow using a combination of natural language and constrained option responses that guide the user to a resolution. These conversations typically take the form of messages exchanged in turns. And one of the most common kind of conversational exchange is a question followed by an answer. This pattern forms the basis for many user support bots and can often be based on existing FAQ documentation. To implement this kind of solution, you need a knowledge base and a bot service. So, what is a knowledge base? To implement this kind of a solution, you need a knowledge base of question and answer pairs and a bot service. So, what is a knowledge base of question and answer pairs? It is usually some built in natural language processing model to enable questions that can be phrased in multiple ways to be understood with the same semantic meaning, and a bot service that provides an interface to the knowledge base through one or more channels. So, when designing a bot, developers should consider some of the following guidelines. Be transparent about what the bot can or can't do. Make it clear that the user is communicating with a bot. Enable the bot to seamlessly hand off to a human if necessary. Ensure the bot respects cultural norms. Ensure the bot is reliable. Respect user privacy. Handle data securely. Ensure the bot meets accessible standards, and assume accountability for the bot's action. So let me demonstrate how a bot system looks like. So I'm going to go to a Microsoft Research deployed bot. So this is designed for healthcare. I'm going to click on try a demo. So let me ask some question. So I'm going to ask for a question which is not mentioned here. So I asked, I'm having a headache, but the spelling was wrong. But the bot is asking, did you mean I'm having a headache with the correct? I'm going to select yes. So it is asking me to provide some additional information. So I'm going to give none. I'm going to put my age, select the gender, how strong is my headache. As you can see that the bot is collecting a lot of information which is required before proceeding me to the hospital or taking my case to the doctor. No, I don't have a sore throat. Do I have a similar headache in last 3 months? No. How long have you had the headache before? Like, I just select 1 hour. I'm going to select yes. As you can see that the bot is asking a lot of questions and I'm going to respond with my responses, and it is tracking all the data. So you can build in your own solution to smoothly hand over the information after collecting from the patient and redirect that to the doctor as well. So after I provided all these responses, it given me a summary, my age, gender, and initial complaint, and other problems and symptoms. Based on the answers I have given, in the suggested care, it requested me to call an ambulance, and it said that the possible cause is because of a carbon monoxide poisoning. As you can see that this is one classic example of creating a conversational AI bot. So let's learn about what is the Q&A Maker service. The Q&A Maker is a cognitive service that enables you to define a knowledge base of question and answer pairs. You can create the knowledge base by entering questions and answers, or you can import an existing frequently asked question list. And you can also augment your questions and answers with a built-in chit-chat sources that include common conversational exchanges as well. After creating the knowledge base, you train a model based on the question and answer data and publish it as a service. Client application and particular bots can then consume the knowledge base and use it to determine appropriate response to user inputs. And Azure Bot Service provide a platform for creating, deploying, and managing bots. With the Azure Bot Service, developers can use the Microsoft Bot Framework SDK to develop bots and easily deploy and manage them in Azure. By using the Azure Bot Service, you can easily integrate your bot and Azure Cognitive Services like Language Understanding and Q&A Maker and connect your bot to multiple channels to support as web chat, email, and Microsoft Teams and others. So we have completed all modules which is required for this AI 900 fundamentals. And I wish you all the very best for your continued success. I will see you on the next examination course. Till then, take care.